Welcome back to our lessons. This moment we want to look at a recap of frictional force that we can also give you an animated version of this content. And just to go through what we had already covered, the first part we defined the frictional force and we said it is a force that opposes motion between two surfaces that are in contact. So this definitely tells us something that a frictional force is a contact force. So moving to the next part, we also talked about frictional force in fluids, whereby we have liquids and gases, and that is called viscous drag or viscosity. Frictional force is a constant contact force and it acts in the direction opposite to that of motion of the body. And I believe if we watch this next video, then we'll be able to have the best of what we have. So there is this video here. I want to play it so that you can check. We have somebody there who is trying to move that particular object, and you can see is pushing. That is a force. So force exerted by the man is towards that direction shown by the blue arrow. Then the relative motion, you can check that. And then as you follow through, you realize that this particular man is as he's pushing or is exerting the force, then we have another force down there, force due to friction, that is opposing the motion. So that one highlights or shows us, illustrates the frictional force that we are talking about. So we talked about these advantages of frictional force, whereby we said friction helps us in writing, it helps us in braking and walking, erasing, and lighting of a matchstick, and very many other advantages. But this friction also has some disadvantages. We highlighted them in our first class. We said one of the disadvantages that is that it causes wear and tear. Then it hinders motion. It also produces unwanted heat. And finally, it produces unwanted sound. So what are some of the methods of reducing frictional force? Usually, we've seen in our family setups, when we use the wheelbarrow, we usually add oil or some grease there so that we can reduce the friction. There is also another way of using rollers if we want to move or to reduce the frictional force. Then if we are talking about fluids, that is the liquids and gases, we can introduce streamlining of the bodies. Then we have smoothening the surfaces that are involved. We can also use the ball bearings and air cushioning. Those are some of the methods of reducing frictional force. Moving forward, we also want to look at electrostatic force. When we talk about electrostatic force, this is a force of attraction or repulsion between electrically charged bodies. And as we can say, this is an uncontact force, and there are two types of electrical charges that are involved, because we have already defined it as a force of attraction or repulsion between electrically charged bodies. So these particular charges we are talking about, which ones are they? So we are saying we have two types of electrical charges. The first charge is the positive charge, and the second one is the negative charge. Attraction occurs between unlike charges, that is between the positive and the negative, while repulsion occurs between like charges, that is positive and another positive charge, and negative versus another negative charge. That is the first part. Looking at what we have now, you can see up there we have positive charge and a negative charge in the first case, that is attraction. Then we have positive and positive, that gives us repulsion. Then we have Negative and negative again, those are like charges, they give us repulsion. What are some of the examples of situations in which electrostatic force acts? So the first one, a plastic ruler or pen rubbed with a piece of dry cloth or hair attracts pieces of paper. This is a very good example which we have already done from primary school up to our secondary school. Now we're talking about it. When you were in school, your teacher asked you to rub your ruler or a pen on your hair, and then you took it close to small pieces of paper. Then this showed you that those small pieces of paper were attracted. This is electrostatic force. Then, because at the end of the day, the ruler became charged, it is electrically charged, therefore being able to attract the small pieces of paper. Then we have a wiped glass window which rapidly attracts dust due to charges left on them during the wiping. You know, as we wipe windows, we charge the windows. Therefore, once they are charged or they become electrically charged, we activate the electrostatic force of attraction in them. Therefore, they are able to pick dust particles from the surrounding. Then we have another example. We have polished shoes rapidly attracting dust due to the charges left on them during brushing. Usually, on a dusty environment, once you brush your shoes and you shine them well, as you move from one place to the other, you realize that they quickly attract dust particles. That is because the brushing process leads to charging or electrically makes the shoes become electrically charged, therefore having the ability to attract the dust particles. Then we have a nylon cloth produces cracking sound and sticks on the body when being removed. That is because of the rubbing process that takes place, and we are having the nylon becoming electrically charged, therefore causing that attraction. Then moving on, we have another set of forces, which is the action and reaction. Action and reaction force. I believe you can see that. Action and reaction are two equal forces acting in opposite directions. And as we proceed, you'll be able to see a video which shows you the directions as we have stated them. Then these action and reaction are contact forces because we must be dealing with a block or a body placed on another surface. For example, here we are talking about when a block of wood is placed on a table, its weight, which is the action, acts on the table. The reaction of the table, which is the opposite force, acts on the block. So you can see that diagram there, very good one, illustrating the action and reaction force. So the action is acting downwards, it's acting on the table, then the reaction is acting on the block, and you can see we have those two forces and we have said they are equal and opposite. Then now here we have a video which is going to help us check on that concept of action and reaction. So the block given in the video there is placed on a road surface, and there is a gentleman there who wants to pull, but before pulling, I want us to concentrate more on the block. You can check the blue arrow pointing downwards. That is now the action force, which is acting on the ground, which is the road. Then there is that another arrow labeled R, which is acting upwards. It is a force acting on the block and it's acting upwards. Therefore, we end up saying that action and reaction are equal and opposite forces. Then this clip is going to be very important in the next type of force, which is tensional force. And as we move to the next one, let us discuss about it, then we move back to check the video. So under tension force, It is a force which acts on stretched bodies, and usually these are strings, threads, spiral springs, and etc. Tension is as a result of two opposing forces applied one at each end of a body. It is a constant force. So let us check this video once more, which can be able to give us that understanding. Want to forward it to a point where it's going to give us a clear picture. Look at that, gentlemen. There is this force that is going to be experienced through the thread there. One person is pulling on this other side, and then it is also experiencing another force on the extreme end. So you can check there that the force that is applied by the man is at one end. Then there is now tension force, and as we have said, that is the force that is experienced by those bodies which are used there. So that is the tensional force, mostly in strings, in as a result of two opposing forces applied one at each end of a body. So you saw that man pull, and then there is that weight of the body on the other side. That is all about tension force. Then we move to the next one, which is surface tension. And when we talk about surface tension, this is defined as the force per unit length in which the plane of a liquid surface acting at right angles on either side of an imaginary line drawn in the surface. So, a molecular explanation of surface tension. A molecule deep in the liquid is surrounded by liquid on all sides so that the net force on it is zero, while a molecule on the surface has fewer molecules on the vapor side and therefore will experience a resultant inward force, causing the surface of the liquid to be in tension. So on the upper surface, we are noting that there are fewer molecules on the vapor side, and therefore this will experience a resultant inward force. So this resultant inward force, is the one that is causing the surface of the liquid to be in tension. Then we have some examples of situations in which surface tension force acts. For example, when a steel razor blade or needle floats when carefully placed on the water's surface, although steel is denser than water. You will note that the steel needle that has been placed on the water surface does not sink, although it's denser than water. That is as a result of the surface tension force that is being experienced. Then, when we have a glass of water that can be filled with water above the brim without water pouring out, this is due to the surface tension on the surface of water. So that is also another good example. Then another example is bristles of a brush spread in water but cling together when the brush is retrieved out of water. The clinging together of bristles is due to the surface tension of water on the surface of bristles. Then a drop of water from a burette or water tap grows and stretches out before it falls off due to surface tension on the surface of the drop. So it appears spherical as it drops down. So that is as a result of surface tension. Then we can also note that surface tension acts along the surface of a liquid so as to reduce surface area. This can be illustrated by the following observations. One, when bubble of a soap is blown to the right end of a funnel and the left with the upper end, the bubble reduces slowly until it flattens the surface as small as possible. So you can check those diagrams there. That soap bubble flattens completely to that end part as and it becomes as small as possible. Then we can also look at the second one. When a film of soap contained in a wire loop is punctured or pierced at point X as shown below, the remaining part of the film acquires a minimum area. The thread is therefore pulled from one side, making a perfect curve. This is because of forces of surface tension from one side only. So as you can see, those are also two cases of surface tension. And the first one for the funnel, I believe you've tried it using your bare hands. Maybe when you have mixed Omo with water, we tried to rub, then we blew. At one point, we were able to form a very big bubble. That is the soap bubble we are talking about. So now, as we move along, you can see how it is flattening. Then now, this surface tension can be affected by some factors. And the first factor we want to talk about is impurities. We want to look at impurities like soap, like paraffin being added to maybe liquid like water. Impurities reduce surface tension of a liquid. Soap detergent weakens the cohesive forces between the surface liquid molecules and therefore reducing surface tension. So that is when we add impurities to a liquid, we reduce the surface tension. So we can also talk about temperature. When temperature is reduced, surface tension of the liquid, temperature reduces the surface tension of the liquid because it weakens cohesive force of attraction between the liquid molecules. Now, using these two factors, somebody can ask you a very simple question here and ask you to state two ways in which surface tension can be reduced. State two ways in which surface tension can be reduced. Under this, you are expected to talk about reducing impurities. That one will help, it will reduce surface tension. Sorry, reducing, adding impurities, adding impurities reduce the surface tension. Then we have increasing the temperature. So we add impurities, we also increase the temperature. By so doing, we are going to reduce the surface tension. But if we talk about increasing the surface tension, then we are going to talk about reducing or decreasing the impurities in the liquid. Then again, we reduce the temperature in the liquid. Those two ways are going to help us increase the surface tension. But when we add impurities, we are going to reduce the surface tension. When we increase the temperature, we are going to reduce the surface tension. Then we have some questions here for students to go and attempt. I believe they are very good questions. Okay. We have the first one explaining the following observations. A steel needle placed carefully on the surface of water does not sink. When that is the first one, so we've seen it is as a result of surface tension, the stretching surface as a result of the inward forces acting on the surface of the liquid. Then we are talking about when a small drop of detergent is placed on water, the floating needle moves rapidly away from it and sinks when more detergent is added. Now this is a question that is captured from the concept on factors affecting surface tension. So as a student, you should know how adding impurities affect the surface tension. So that one you can be able to explain it using the factor of impurities, and in this case it's all about adding impurities. Then the next one, a matchstick wrapped at one end with soap starts moving immediately in one direction, still under impurities. So students can be able to make a good answer from that part. Then the next one is adhesive force. So we have these two forces, adhesive and cohesive force. Adhesive refers to the force of attraction between molecules of different kinds. For example, force of attraction between water and glass molecules. Then we have some of the examples or situations in which adhesive force acts. We have a liquid wetting glass. We also have paint sticking on walls. Then we have ink sticking on paper. Then we have chalk mark sticking on the board. Then there is this other sister force. We talked about adhesive. Then we definitely have to talk about cohesive force. Cohesive force refers to the force of attraction between molecules of the same kind. For example, the force of attraction between water molecules. Somebody else can say between mercury molecules. Somebody else can give an example of glass molecules. Those are molecules of the same kind. What are some of the effects of adhesive and cohesive force? Can see those capillary tubes dipped in water. Under the first diagram there, you can see water in those tubes, water rising in those tubes. At the end of the day, we'll be able to deduce that the narrow tube water was able to have a higher column in the narrow tube as compared to the wide tube. Then we say in both capillary tubes, water curves upwards at the edge. That is, it wets the glass. The rise of water up the tube is due to adhesive forces between glass and water molecules being stronger than the cohesive force of attraction between the water molecules. So in this case here, you can check now that adhesive forces are stronger, forces of attraction between molecules of different kinds compared to cohesive force of attraction between molecules of the same kind. So the force of attraction between water molecules and the glass molecules was stronger than the force of attraction between water molecules. That is why we have the water rising and sticking on the walls of the glass. Then the upward curve that we are experiencing under that part, this one here, that upward curve is known as the concave meniscus. Then we have now another example under which we are using now mercury. The first one we had used water. When we talk about mercury here, you can check what is happening. Now the curves are different. They are not inwards. We have downward curves. So the level of mercury in the capillary tubes is lower than that of mercury in the basin, being lowest in the narrow tube. So you can see they are changing. In the other case, in the narrow tube we had the highest, that is for water. But now when we are using mercury, the narrow tube has the lowest height. So in both capillary tubes, mercury curves downwards at the edge and it does not wet the glass. This is because we have very strong cohesive force between mercury molecules than the cohesive force between the mercury and the glass molecules. So you can check the downward curve. That one is called convex meniscus. Then about the behavior of water on a clean and worked surface or glass surface. If you check those diagrams, then in the first case, in a clean glass surface, a droplet of water will spread, while on a worked glass surface, the water droplets will form balls and roll on the surface. So now, when water is dropped on a clean piece of glass, it spreads because adhesive forces between glass and water molecules are stronger than cohesive forces between water molecules. So in the first case, we are talking about stronger adhesive forces between the molecules of the glass and the water molecules as compared to the cohesive force, that is the force of attraction between water molecules. But then when we move to the next one, we realize that the cohesive force is stronger in the water molecules. That is, when water is dropped on wax surface, it rolls into small drops. This is because waxing reduces adhesive force between water and the glass molecules. So there is a reduced cohesive force. Then we have the next part, which is mass and weight. We want to find the differences between mass and weight, but first of all, we must be able to bring out a clear difference through definition of mass and weight. So, first of all, mass is defined as the quantity of matter in a body. Then we talk about weight. Weight is the gravitational pull on a body, and weight is definitely a force, and it is therefore has an SI unit of, which is the Newton. The direction of action of weight on the earth is towards the center of the earth. Now that one brings us to our next part of discussion, where we are looking at the relationship between mass and weight. The relationship between mass and weight. So when we look at mass and weight, we first of all want to look at one as a basic physical quantity and the other one is a derived quantity. So we want to see how we are getting weight from mass. Mathematically, you can say weight is equal to mass times acceleration due to gravity or the gravitational field strength. And we can represent that by the formula W is equal to mg. W is equal to mg, what we have here. So that one takes us to this other part whereby we say we can define acceleration due to gravity as gravitational force acting on a unit mass at a place, and the SI unit is Newton per kilogram. So if we were to draw a graph of weight versus mass, then we'll definitely have a straight line graph through the origin, and you can check the slope of that graph will give us acceleration due to gravity, Newton per kilogram. That is the acceleration due to gravity. Then moving further, now we can check on the differences between mass and weight. Usually, when we give these differences, we have some parameters to use so that we can give these differences well. First of all, we can give the difference based on the definition. And as you can see, our first difference here is based on this definition here. You can check this cursor, the quantity of matter in an object, that is a mass. Again, on that same line, you can give the definition for weight. So that is a difference based on definition. We have gravitational pull on an object. Then we can give a difference based on the SI unit. The difference based on the SI unit. What is the SI unit of mass? The SI unit of mass is kilogram, which is given as the symbol is kg. Then on the other side where we have weight, the SI unit is the Newton. The symbol is capital N. Then mass is a constant everywhere, unlike weight, which varies from one place to the other. Actually, it varies because it depends on the acceleration due to gravity. Then what type of quantities are they? That is another parameter. Mass is a scalar quantity. It only has a magnitude but no direction. But then weight is a vector quantity. It has both magnitude and direction. Then how are these quantities measured? That is also another thing or parameter to check when we are giving the differences. We can say mass is measured using a beam balance, whereas weight is measured using a spring balance. So that difference should be brought out well. So already we have those are 5 differences, and I believe once you get them maybe in an exam, you'll be able to give them out very well. Then from what we have covered, we have some questions which we can go through, which can be able to help us have an overview or a recap of that part of those types of forces. The first question here we have is to state a reason as to why weight of a body varies from one place to another on the Earth's surface. Now, we have talked about the gravitational field strength. This gravitational field strength varies from one place to the other on the Earth's surface, and being strong at the poles and weak at the equator. So that is the key reason. The gravitational field strength varies from one point to the other. Then we can also have a question here under the relationship or the relationship between mass and weight. An object weighs 1000 newtons on the Earth's surface, and we've been given G to be 10 newtons per kilogram. That is the acceleration due to gravity. We calculate its mass. Already we've said weight is equal to mass times G. Now, substituting in this formula here, we can have 1000 N is equal to M times 10 newtons per kilogram. Dividing through and making M the subject here, we are going to have 100 kilograms as the mass of a particular object. So next time they will give you the weight, then they give you the mass, then they'll require you to look for the G. So we should be able to know how to work out using this formula. And as we usually say in physics, it's very important for you to list the quantities given. You write down the formula, then now you start substituting so that you can look for what is missing. That one is a very good way. Then there is another question here. If the same object weighs 160 newtons, that's the continuation of that question. If the same object weighs 160 newtons on the moon surface, find the gravitational field strength of the moon. So that same object, we have already determined its mass to be 100 kilograms. Now we are told that in another surface, which is the moon surface, it is weighing 160. It's weighing 160 newtons. So in this case, we are supposed to look for G, the gravitational field strength of the moon. So we have W and we have M, the answer in the previous part, which was part A, which is 100 kilograms. So in that case, we do the substitution. W is equal to mg, therefore we'll be having 160 is equal to 100 times g. This is what I had mentioned earlier in the part A of this question. I said you can be asked to look for g. So in this question, you can check through the calculations. Our g is equal to 1.60 newtons per kilogram. Then moving on to the other question here, we have a mass of 7.5 kilograms has a weight of 30 newtons on a certain planet. Then we are supposed to calculate the acceleration due to gravity on this planet. So in this case, we have mass, we have m, then we have the weight, then we are supposed to look for g. Again, using the same formula, we are expected to substitute. W is equal to mg. Our W is 30, as you can see. Our M is 7.5, and our G is what is missing. So considering G as the subject here, we divide both sides by 7.5. Our G becomes 4 Newton per kilogram. And remember, students, when you're working out this, ensure that your mass is in the SI unit, which is the kilogram, so that you can be able to get it correct. That means that if you have been given maybe 500 grams, then you have first of all to change the 500 grams to kilograms. We use the units in their SI unit form. Then there is another question here, number 4. A man has a mass of 70 kilograms. Calculate part A, his weight on the earth where the gravitational field strength is 10 newtons per kilogram. So we are looking for the weight. We already have the mass and we have G. So the same formula, W is equal to mg. We have M, we have G, so we are looking for W. So substituting in the formula, we have 70 times 10 to give us 700 newtons. Then part B, we have his weight on moon where the gravitational field strength is 1.7 newtons per kilogram. So the same man who weighs 70 kilograms now moves to the surface of the moon where the G changes. Still, we are going to apply our formula. W is equal to mg. And in this case, our M is 70 and our G is 1.7. Compiling and using the 2, multiplying 70 times 1.7, we are going to get 119 newtons as the weight of this particular man in the surface of the moon. Then we want to look at some of the last parts of this topic. We have scalar and vector quantities. Under scalar quantities, we want to find the difference. A scalar quantity, this is a quantity which has only the size, what we call magnitude, but it doesn't have the direction. Some of the examples of a scalar quantity are time, temperature, energy, speed, area, volume, length, mass, and distance. These are examples of scalar quantities. Then we have vector quantities. A vector quantity is one with both magnitude and direction. So we have some of the examples there: weight, a force, velocity, momentum, acceleration, displacement. All these are examples of vector quantities. Then if we have a question here which we need to, a statement which we need to look at, and then we look at resultant vector. If the weight of a car is 8,000 newtons, 800 is the magnitude of the weight. Then Newton is the SI unit and the direction is towards the center of the earth, because weight is a force, weight of an object acts towards the center of the earth. So in that case, we'll be able to explain what 800 newtons of a particular body is. We are saying 800 is the size or the magnitude of that particular weight. Then we have N is the SI unit and the direction is towards the center of the earth. Then we have resultant vector. A resultant vector is the sum of two or more vectors taking into account the direction of the vectors. Under this part, we want to look at examples. If we have two forces acting towards the same direction, then the resultant force will be the sum of the two forces. So like the example we have here on our screen, the two forces are 4 newtons and 5 newtons acting towards the same direction. The resultant is the sum of these two forces. So we are going to have 4 newtons plus 5 newtons to give us 9 newtons. Then we have another example here, example B. But then back to the first example, once you've determined the 9 newtons, you must draw it and show that it's acting towards that very direction. Then we have part B. You can check the body there, body D. We have forces acting on the point B. Two forces are acting towards the right, that's 4 newtons and 2 newtons, and two other forces are acting towards the left, 7 newtons and 3 newtons. So when we talk about resultant force, those acting towards the same side will find their sum. Then again, we find the sum of those acting towards the left. So at the end of the day, we are having a scenario of 10 newtons acting towards the left, and 6 newtons acting towards the right. That means that the force acting towards the left is more than the force acting towards the left. When we are talking about resultant force of forces acting towards opposite directions, then we are going to subtract. So in this case, we are having 10 minus 6 to give us 4 newtons. So that is the representation that we have here on the screen. Then finally, we have some questions which students are highly encouraged to attempt. And these questions are found in the KLB course book. And I believe if you take your time well, you can be able to answer them. And if you have a question, kindly reach out to the comment section so that you can leave us your questions so that we can be able to respond to them in our next lesson. So all those are questions from the topic. They still have solutions here, but I think it's good for students to attempt so that when we meet in the next lesson, we can be able to have the starting point. Thank you. That is from our side today, and that is the end of the topic for us. And we meet in the next lesson so that we can look at another topic. Thank you.